Welcome. Let's look at the problem that was posted for classroom discussion. Here, as we talked, what Luke is trying to do is to minimize his cost while satisfying some exposure requirements. As you know, he has 3 places to advertise: Beach Watch newspaper, Surf and Tan, and billboards. So the decision he has to make is how many ads of each type to place and still meet the conditions specified. You are given that each Beach Watch ad costs $400, Surf and Tan ad costs $200, and billboard ad costs $600. So the decision you have to make is how many of each to advertise. In other words, your decision variables are number of Beach Watch ads, number of Surf and Tan ads, and number of billboard ads, subject to the conditions that are laid out in the problem so as to minimize cost. So the objective is to minimize cost, and decision variables are the number of Beach Watch ads, number of ads in Surf and Tan flyer, and number of billboard ads. So we want to first specify those variables. N is number of Beach Watch ad newspapers, S number of ads in Surf and Tan, and B is the number of billboard ads. An objective is to minimize cost. Now, how do you calculate cost? If N is the number of Beach Watch newspaper ads, say if N is 1, then the cost is 400. If N is 2, then it's 400 times 2, 800. If N is 3, then it's 400 times 3, and so on. Same thing about S and B. So what you are also told is that Luke has a budget of 6,000. So that means he can't spend more than 6,000. So you write that budget equation, or the cost on 3 ads has to be less than or equal to 6,000. Then you also know that Luke wants to reach at least 5,000 of under 20 crowd. Now, regarding under 20 crowd, each Beach Watch ad reaches 100, Surf and Tan ad reaches 100, but billboard ad reaches 700. So again, knowing N, S, and B, which is the numbers of those ads respectively, 100N, which is the exposure to under 20, plus 100S, exposure to under 20 by Surf and Tan, and 700B, exposure to under 20 by billboard. That has to be at least 5,000. Similarly, you want 3,000 exposure for 20 to 40 age-old crowd. Same logic, 200 is exposure by Beach Watch newspaper ads, so 200N plus 400S plus 200B has to be greater than or equal to 3,000. And similarly, for over 40, you want exposure of at least 2,000, and therefore you have 500N, where 500 is coming from here, plus 200S plus 200B to be greater than or equal to 2,000. Then you are told that he wants total exposure among the 2 age groups, 20 and over to be no more than 75% of the total exposure. So total exposure is the sum of exposure by Beach Watch newspaper, which is 100 plus 200 plus 500 multiplied by n. Similarly, exposure, total exposure by Surf and Tan is sum of 100, 400 plus 200 times S. And similarly for billboard ads, 700 plus 200 plus 200, which is 1100 times B. And so that's what you have here, 800N, which is 100 plus 200 plus 500 plus 700S, 100, 400 plus 200, and similarly 1100B. 75% of that. And then you also calculate the exposure to 20 and over. So 20 to 40 is 200 and 40 plus is 500. So 200 plus 500 multiplied by the newspaper ads. Then similarly 400 plus 200 times S plus 200 times 200, which are your billboard ads, multiplied by B. This amount has to be less than or equal to 75% of the total. And when you simplify, in other words, bring the right hand side to the left and simplify it, in other words, 700 minus 0.7 times 800, like 0.75 times 800 is 600. Subtract that from 700, which gives you 100N, so that's here. And similarly for S and B, and that gives you this constraint, and the obviously non-negativity constraint, because you can't have negative ads. The only other assumption we sort of make is that you can have fraction of an ad, because you're doing this on an ongoing basis. So to solve it, how would we write in Excel? Now in Excel you obviously cannot write N, S and B. So for that we have to write some number. So we say number of ads, we just randomly pick a number, 1 for newspaper ads, 2 for Surf and Tan, and 3 for the billboard ads. Then cost of ads is 400, 200 and 600. So here we could just modify it. You can write cost per ad. So that gives you 400, 200 and 600. And then when you multiply it, the total is 2600. You can obtain this two ways. One is you say 400 multiplied by 1 plus 200 multiplied by 2 plus 600 multiplied by 3, and that's the formula you would see if you press F2. So that is the formula you enter. Or you could have written sum product. And this total has to be less than or equal to the limit, which is your right hand side, that is 6,000. That's what we saw in the description, and that is this constraint that you have. So 400N plus 200S plus 600B, which is 2,600, has to be less than or equal to 6,000. Similarly, our next constraint is 100N plus 100S plus 700B has to be greater than or equal to 5,000. And again, same thing here. So you can do the same calculation that we did if you want to use the formula. Then the formula is sum product B2 to D2, which is here, multiplied by respective cells in B5 to D5, which is here, right? So that you can write that to obtain the product, and this has to be greater than or equal to 5,000. Similarly, we do the calculation for exposure per add to 20 to 40. So this is 200, 400 and 200, and then total exposure for ads of 1, 2 and 3 respectively is 1600, which has to be greater than or equal to 3000 because you want the exposure to be at least 3000. Similarly, you have the exposure of 40 plus. And this is your additional constraint. If this is confusing, I could just expand that. Right? So that was the additional constraint that we had, 100n plus 75s minus 425b less than or equal to 0. So we have 100, 75, 425, which are coefficients of n, s, and b. And then sum product, which gives you the product of 1, 2, and 3 multiplied by the additional cost respectively. And so that gives you negative 1025. That has to be less than or equal to 0. And then you have the non-negativity constraint. So how would we now solve it? To solve it, you again say data, and then you go and pick solver, and then we want to specify the target cell, so which is cell E1. So we say this is E1. Now we are not maximizing, which comes by default. Since we are minimizing, we say minimum. Then what are our changing cells? In other words, what are our decision variables? These are cells B2, C2, and D2. So you choose that, or you could have typed that in. Then you want to add the constraints. So you check on add, and the left hand side for the first constraint, which is the budget constraint, is this amount has to be less than or equal to the right hand side. So since we are adding constraints, you say add. Then our next exposure constraint is exposure to under 20. This amount has to be greater than or equal to. So you select here greater than or equal to, and then you put the constraint here by saying this has to be greater than or equal to. Then we are still adding constraints. And then you can, since these are together, that's another way you can enter. So in one step, so you say these two numbers are respectively greater than these two numbers. So in other words, E6 is greater than or equal to G6. E7 is greater than or equal to G7. Now we still have one more constraint to add. So we say add, and then we say this, and this is less than or equal to the right hand side. And then you can add the non-negativity constraint. You can say add, and then you select the 3 and say these are greater than or equal to 0. And since this is the last constraint, you say OK. And then you say solve. And when you solve it, it asks you, do you want the final solution or do you want to restore to original values? So that's your call, and so here I can, if I say cancel, you got the original values. And if you now again go and say solver, this was the table we had. So for your record, I would just make a copy of this and post it. So I just use the snipping tool and then just copy it and then paste it here. So this, you can see the cells that, the constraints that I have added. So we'll stop there. And if you wanted to keep the constraints, you can say data analysis, solver, and solve, and these are your answers. So we say keep, and then if you wanted to submit the answer, the way you could do it is, again, I have highlighted the numbers here. So this is our objective function, cost function is this, which is what we are trying to minimize. Our decision variables are number of beach watch newspaper ads, number of ads in surf and tan, number of billboard ads. And these are our constraints that we had entered. And then, to provide the solution for the answer, we see that the value of n is 0, s is 4.23, b is 6.53, and the minimum cost, which is our objective function, is 4769. So we'll stop there, and I suggest you pick other problems from the problem set and work on them.